All right, need to talk about Venus. If you pay attention in class, I'm pretty much going to recover the same thing we just went over, but let's hit it one more time. A couple things you need to know about Venus. Venus is about the same size as we are. It has about the same surface gravity because it's about the same size. It's almost the same density. So therefore, Venus was considered by a lot of people for a long time to be the most Earth-like planet. In fact, it's the closest to us. It's a little over 2/3 of the way to the Earth. And so it's a hop, skip, and a jump. It's a rocket ship goes off, hits the brakes, can fall to Venus. There's some logistical issues, but for the most part, it looked like Venus was the next place to go. In fact, during the space race, which is part of the Cold War, the United States and Russia were racing. The Russians put up a satellite, so we said, okay, fine, we'll be the first one to orbit one. Then they orbited first. Said, okay, fine, we'll be the first person to put a man in space. Put a man in space. They put a woman in space just to make fun of us. And then we said, well, we'll do the first spacewalk. Put a guy up there and walked in space and, waved at us. Said, okay, we're going to put up a sky lab. They put a lab before we did. So we said, okay, fine, we're going to go to the moon first. Now the Russians, time that's called the Soviet Union, built rockets to get to the moon. But unfortunately, they were fairly unstable and started blowing up the launch pad. They were actually much more powerful than even our Saturn V, which is a huge rocket. Our Saturn V is a monstrous 400 feet of pure fuel, little tiny capsule on top, size of basically a big closet. And that is basically what we launched at the moon, and we made it there first, landed there, and said, aha, we win. To which the Soviet Union looked at Venus and said, we're going to beat you to Venus because we got a bigger rocket ready to go. There's a problem. What's the problem? Well, Venus looks very habitable. It looks like the same size planet, same everything. The atmosphere has pretty clouds in it. The first thing that the Russians noticed that was wrong was that there was, in fact, a problem with those clouds. The clouds were actually sulfuric acid. Then you might think, oh, gosh, well, that means that we can't go there. But that's not that big a deal because if you think about it, there's no water, sulfuric acid doesn't work. Chemistry 101. So then the Russians thought, you know what? We'll put some probes, we'll land them on the surface. And over again, Venera programs tried to land on the surface of Venus, and they just did not make it. They could not figure out what was going on. It was a little while later they suddenly discovered the problem. The problem is the atmosphere of Venus is 92 times what ours is. It's a thick, heavy, oppressive atmosphere. This atmosphere also is mostly carbon dioxide. But because of that, because of what's called the greenhouse effect, remember the greenhouse effect is what you feel when you drive to Reno and you park your car in the parking lot on a summer day. By the time you get out there, your car is 120 degrees. It's because light can go into the thing, but it can't. But the heat can't get back out. So if you've got your basic car sitting here, your basic car, oh, let's see if I can draw. I can't draw. Let's see. It will let me draw. No, it won't let me draw. That's too bad. So if you got your basic car sitting here, driving down the road, boop, ba-doop, 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 now not driving down the road, sitting in the parking lot, light can come in through the window, strike your seat or whatever. That gets re-emitted as infrared. Infrared can't get through light because infrared is heat and glass the conductor is a insulator versus heat. So light keeps coming in. Heat can't get out. Your car gets hotter and hotter until you open the door and go, oh gosh, we have to drive this car. Somebody turn on the air conditioning. So same thing happens with Venus. Venus has a layer, an atmosphere, and it's got carbon dioxide in it. And so light can come in, but the heat trying to get back out is stuck. It's trapped. And so the surface temperature of Venus is about 864 degrees Fahrenheit. There's some disagreement because, again, we don't have great measurements of the surface of Venus because it's trouble to get in there. If you think about it, we spend a lot of time and effort trying to figure out how to get through the atmosphere of Earth to land back on planet Earth. It takes heat shielding, it takes slowing down, it takes parachutes, it takes landing in the ocean, it takes retro rockets and all sorts of things because you can't just slam into the surface of the Earth, surface of the atmosphere, it'll burn you up. Well, we're now 92 times. So we've had some luck, very little luck, trying to pierce those clouds. So what have we had? Well, we have some pictures. Let me give you some pictures that might be of use to you. This is what it looks like on the surface of Venus. Like, oh gosh, it's orange. It's so pretty. This is actually a radar image. We sent a probe, and a probe circled around Venus, took great gravity measurements, and because we didn't want to try to land through the clouds, this probe sat there and circled and took radar images. That little line through the middle there, that is in fact a large valley. It goes around the length of it. Now you're thinking, okay, so I really can't tell what the surface of Venus is. When we were talking about craters enough times, we want to know. So we eventually crash landed the probe inside. While it was on its way in, burning up, we said, take many pictures you can with your radar. And we got one more good picture out of it. It looks like this. And I do want to make it bigger, so let's see here. Now again, the black is stark. It wouldn't be black, it'd be a very glowish atmosphere. What is this? Is radar. Radar's not bouncing off the atmosphere. We intentionally set it that way. So this is a mountain. That's actually a volcano in the foreground. There's rumpled ground. There's indication that they have plate tectonics like we do. That includes things like volcanoes, valleys, and such like. It does have rain. There are surfaces that are made by rain, but remember that rain is sulfuric acid, so what's coming down from the sky is a different sort of beast, but not as bad as you would think. Again, that atmosphere is 92 times stronger. To put that in perspective, 900 meters underneath the ocean is about the same pressure. At that pressure, at 400 meters during World War II, submarines would crack from the ocean water, squeezing the submarine to death. So imagine 900 meters, we completely do that. So metal, steel cans would get crushed on the surface of this planet. Temperature is 800 and whatever degrees, so your aluminum can is melting. Lead is melting. So our dreams of landing on the surface of Venus are pretty much gone. It would be very difficult to make a habitable place on this planet. We do have one option, and this is something that NASA is playing with, and if we get lucky, sometime in your lifetime, you have a chance to have this work, and that is they're hoping to make a balloon that floats in the atmosphere. Pretty easy to float in the atmosphere with that kind of density, right? So therefore, they think a balloon, you could float a balloon up there. Yes, it'd be very hot. Yes, you'd have to figure out what you're going to do about that. But the bottom line is you might be able to make a permanent station in the atmosphere of Venus, which would be a lot safer place than the surface. One other thing about Venus that's very important, but it's very important for a reason I'm not going to get into, but you need to know it so that later on when I discuss it, you're like, well, we didn't talk about that. Venus is a very strange planet in one other way. Every object that we can see going around the sun spins in the same direction as it goes around the sun. That includes, by the way, Venus. And if you read carefully all sorts of documents, you'll see, well, no, it says here on Wikipedia it goes the other way. That's because actually the sun rises in the west. Well, if it's turning the same direction, how can that be? Well, because what's very fascinating about Venus and extraordinarily unusual, Venus's year is shorter than its day. Which means the planet is turning so slowly that it goes around the sun before it turns around once. And that's what causes this very strange effect. Venus is going the same way we are around the sun, and because its day is so short, it's so long, the sun moves very slowly across the sky, which you would think would heat one side more than the other side. But as we discussed with Mercury, Mercury has one hot side and one cold side because it turns very slowly and has no atmosphere. Venus turns very slowly, but it has a tremendous atmosphere. That atmosphere is hot all the way around. In fact, the whole surface is hot all the time. It's night 150 days or so. I'm making that number up. Probably more like 120, come to think of it. It is hot for it's daylight 120 days of the year. That said, it doesn't matter. Why? Because the atmosphere is so thick, the heat gets to the other side, it's trapped all the way around. So that is why there's no place on Earth that is super cold or super hot, because we have an atmosphere as well. Which leads us to a discussion of Earth.